The third electrophilic aromatic substitution reaction is the sulfonation of benzene. And we do this using a special reagent. What you do is you take sulfur trioxide gas and bubble that through sulfuric acid. And what that makes is an extra potent mixture known as fuming sulfuric acid. Under these conditions, we end up putting a sulfonic acid group on the ring. So the hydrogen on the ring gets substituted with SO3H, and this is known as the sulfonic acid group. If you want to draw that out, I'll just abbreviate the ring as pH. Sulfur has an expanded octet, so we have 2 double bond O's and an OH. That's what that looks like. For the mechanism, the first part is generating the active electrophile. And what we do is we start with sulfur trioxide. And we mix that with sulfuric acid. And that provides a proton. What we can do is use a lone pair on one of these oxygens, and that will act as a base, and we'll do a proton transfer. So we'll take the lone pair on the oxygen and take a proton from sulfuric acid. By doing that, now we have a positive charge on the oxygen plus the hydrogen sulfate conjugate base. At this point, we have our active electrophile. You could draw the other resonance structure which shows the positive charge on the sulfur. So I can move the pi bond between the sulfur and the OH plus onto the oxygen as a lone pair. And we get the other resonance structure. Or we can just abbreviate this as SO3H plus. And that's our active electrophile. The next step should be getting pretty familiar. So we take our aromatic ring. Again, I'll draw in the hydrogen that's going to be substituted. We react that with the SO3H plus. So we'll pick a pi bond to the ring, draw a curved arrow to show electron flow to that sulfur. We'll add SO3H. And we still have a hydrogen there. And we form a carbocation on the other carbon that was part of the double bond. Now we just need to reform the aromatic ring. We want to use something as a base. So in this case, our best bet is just going to be this hydrogen sulfate. Take that, grab this proton, push those electrons down to reform the aromatic ring.